that sort of thing. All right, so where did we get to? We got to introducing alkanes. We got to looking at 4 different kinds of formulas: molecular, structural, line, condensed. I introduced 2 alkyl groups or substituents. And we'll just look those slides over real quickly here and go on to 4 more. And then that'll lay the groundwork. That'll be all the raw materials we need to go in and start naming compounds pretty routinely. So the first one we mentioned was the methyl group. All right, this is just kind of review, overlapping with Thursday a little bit. That's a methyl group. That is methane. That is a compound. That is not a compound. That is a substituent that we're going to find on molecules here, there, and everywhere. That's probably the most prominent one we'll find. We'll find that one more often than any other one. Methyl groups. And what is it? It's got 3 hydrogens on it, and it has a position right there where it can bind to something. So if you had propane here, and you had a methyl group right there. Okay, that's what we're talking about. That other spot is where it's attaching to a carbon. So there's your methyl group attached to some compound, and then we're going to learn how to name these. The second one, again, very prominent one, is an ethyl group. And maybe we just got far enough to just mention this one. So if you remove that hydrogen and show that as a place where it can connect to something, you have an ethyl group. And you should have, I would suggest you have a 3x5 card. On one side you have that, and on the other side you have its name. That's an ethyl group. You're going to see all of these have a YL ending to them. Ethyl. Don't confuse it with ethane. That is ethane. That's an alkane. This is an ethyl substituent. Ethyl. And sometimes it's written as C2H5. So it can be written as C2H5. You can see there's 2 carbons and 5 hydrogens around it. Or it can be written as a CH2CH3 in a condensed form. It'd be a CH2CH3 group. Ethyl. All right, so far with methane and ethane, if you take off any one of the hydrogens, you end up at the same place. There's no ambiguity. Here's what I'm saying. Here's ethane. Okay, I take that hydrogen off. That's an ethyl group. Does that look any different? No. No matter which hydrogen I take off of there, doesn't look any different. Comes out looking exactly the same. So it doesn't matter what hydrogen I come off, it's just going to be, there's going to be a space on one of the carbons and 5 hydrogens on it, and the 2 carbons are each on an end. There's only 2 ends to this molecule. And likewise, if we were doing this with methane, you know, it doesn't matter whether I take that hydrogen off or that hydrogen off. All right? All the same. Okay. Now, why did I go over that? Because now when we get to 3 carbons, there are 2 different hydrogens on here. These 3 hydrogens are just like these 3 hydrogens. Doesn't matter if I take that off, I get a propyl group. With me? Doesn't matter which one of those 6 hydrogens, these 3 or these 3 that I take off, it doesn't look any different. It's a propyl group. So this is our third substituent. Here is our propyl group. What are we doing? We're taking a hydrogen off of either one of the ends, and we get a propyl. And if you wanted to look at that the way we've been doing the methyl and the ethyl, we're going to have hydrogens all around this thing. And we're going to have a spot right there. Not two lines, just one line. There's your propyl. So far we've got methyl, ethyl, propyl. You say, well, this is N-propyl. Well, why do we have an N in front of there? Well, because propyl, notice here, if I take this hydrogen off, remember, here's what we've been looking at, propyl. If I take this hydrogen off, does it look the same? No, that's different. This is different from that. You see that? So propyl gives rise to two substituents. Normal propyl, that's what the N stands for. Normal, just like ethyl and methyl and ethyl. Propyl, just like those. You took a hydrogen off the end. It's normal. This is isopropyl. It's still a propyl substituent, 3 carbons, but it is distinctly different from this one. So this is an isopropyl group. There's where it's going to attach to a chain somewhere. It is an isopropyl group. And you're going to get familiar with the word iso and isomer. An isomer or isomers are two things that have the same formula but different structures. That has the same number of carbons and hydrogens as that does. They're just attached. They've got different structure. We have the opening right here and not here. And it makes a difference. So now we've got 4 substituents: methyl, ethyl, propyl, and isopropyl. And propyl can also be seen as an N-propyl, so it kind of has a nickname, N-propyl versus isopropyl. Okay? And then when you get up to 4 carbons, it gets even trickier. This thing here can give rise to 4 different substituents. This is a butyl group, and if I take a hydrogen off of there, we're going to just call it, this is butane. This is butane. That's a compound. That's an alkane. But we're going to take a hydrogen off of the end, and it's going to be a butyl group. But there are 3 others. I'm going to only really hold you to one other. So that's that one. So that's butyl. And the other one is going to be, this is kind of crazy. If I took that hydrogen off of there, still got 4 carbons. It's kind of strange arrangement here, but that is a tertiary butyl group. Tertiary butyl. Let's get a, so normal butyl is just going to be 4 carbons. Secondary butyl is another possibility. Isobutyl is another possibility. And then here's the tertiary butyl that I'm talking about right here. So tertiary butyl kind of looks like this. And there's where it attaches. So you got hydrogens all around your tertiary butyl. So this is called tertiary butyl, or it's called tert butyl, or it is just abbreviated as T-butyl. All just referring back to that first word, tertiary. It's got a tertiary carbon right here. I'll dwell on this a little bit more in chapter 12 when we get to primary, secondary, and tertiary alcohols. What are those? Well, we'll just have to kind of get there. But just for right now, this carbon has 3 carbons attached to it. So it's a tertiary carbon. Yeah, so in just the butyl groups, there are primary and secondary carbons, but here's a tertiary carbon. So the 4 are methyl, or the 6, methyl, ethyl, propyl, isopropyl, butyl, and tertiary butyl. Those are the 6 substituents you should be pretty comfortable with. You know, I'm not trying to turn you into organic chemists. I mean, we could go into all 4 of those that are on the butyl group. We could go deeper into all this stuff, but I want you to be exposed to enough of it that you understand what these things are, how they're being used, and if you come across something different other than what we've learned, you could figure it out. Okay, so those are the 6 substituents, and we're now getting close to being able to start naming things. Methane, ethane, propane, butane. So there's the structural, the condensed formulas. 2-methylpropane. Okay, I need to come back and talk about this. Well, let me introduce it right now. Notice that this molecule has 2 names. It has 2 names. Well, we'll come back. This is the IUPAC name. That's the IUPAC name of this. So let's get familiar with IUPAC names. Line structures. There are cyclical. No, I don't think we're there yet. This talks about primary, secondary, and tertiary carbons. I'm going to push this into chapter 12. I don't lean heavily on this till we get to alcohols. Okay. So now there's going to be 6 rules. Let me just put over here in our bin. We've got 2-methylpropane, and we have isobutane. So this is for later, but I don't want to forget it. So there are going to be 6 rules, and we need to understand. Rule number 1 is the most important rule. One other thing to understand is that these rules are not just for chapter 10. We are going to apply these rules to alkanes. We're going to learn what these 6 rules are and use alkanes to kind of learn the rules. But we're going to come back to these rules in chapter 11, 12, 13, 14, and 15. we'll always come back to rule number 1. I'll be constantly saying, what's the longest chain? This is rule number 1. Find and name the longest chain of carbon atoms in the formula. So we'll start out here looking at some structures and try to figure out how IUPAC would name them. And then we'll also put a couple names up and say, how would you draw them? If this was the IUPAC name of the molecule, how would you draw it? So, rule number 1, find and name the longest continuous chain of carbons. Longest chain may bend and twist. It is seldom horizontal. All carbon groups not part of the base chain are called branches or substituents. These carbon groups are also called alkyl groups. In rule number 1, we're going to kind of gloss over the substituents and hunt for the longest continuous chain. So let's get an example. So let's look at this molecule. How many carbons are in the longest continuous chain? Now continue. How many? 1, 2, 3, 4, 5. Those 5? How many? 8. Where do you get 8? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Is that what you mean? There are 8 carbons there.
6.
But consider putting your finger on here, and you can't go over the same carbon twice. 1, 2, 3, 4, 5, 6, 7. That is not a part of the continuous chain. 7. 7 carbons. All right, so because this goes down here doesn't matter. That doesn't matter. You know, it doesn't matter if it bends down there. I could be talking about butane. Could look at butane. I probably need a little longer molecule. There's butane. That's still butane. Okay? There's 1, 2, 3, or 1, 2, 3, 4, kind of in a line. And you can see it's not in a line. It does zigzag back and forth. That's butane. But this thing can rotate down like that. It's still butane. That hasn't changed its basic structure. Still the same molecule. It's in a little different conformation. Okay? All right? You can, you sit down in a chair, it's still you. You're in a new conformation. You stand up, you have the same structure. You just changed your conformation, the situation you're in. So this molecule these bonds can rotate all around, and it doesn't affect the chain length. 4 carbons long. All right? So that's 7 carbons long. And now we can also, let's see what rule number 1 again. Find and name the longest chain of carbon atoms. All right, so let's pretend for a moment that's not there. And we have an alkane which got 7 carbons. Heptane. We have not completely named this molecule, but what we have right now is the parent name of the molecule. It is a heptane. Let's see if we have another example. Okay. Rule number 1. Find and name the longest chain. One, 2, 3, 4, 5, 6.
Or could you go like that?
Yeah, you could. 7. Where's 7? 1, 2, 3, 4, 5, 6, 7.
Oh, you can do that. Yeah, but like if you there's 8.
1, 2, 3, 4, 5, 6, 7, 8. That's the longest chain.
I have a question.
Yes.
So the on the last one, heptane is hep the for 7. Is that what that
Yeah,
is?
yeah,
So
hep-
this would be octane. Or?
This would be octane.
Okay.
This would be octane. Now, yeah, keep in mind that, okay, so we have this as the longest chain. And it's 8 carbons long. And what have we ignored? We've ignored this. We haven't gotten to rule 2 yet. 2 and 3, okay? So we're ignoring that. But the longest continuous chain can bend and twist any which way you want to. This is an octane, because there are 8 carbons in it. Rule number 1. Now let's look at rules 2 and 3. Identify and name substituents, and then number the carbon atoms in the chain, in that longest chain, starting from the end closest to the first branch. All right, closest to the first branch. So we are going to decide where this chain starts, and where it starts is going to be carbon number 1. It doesn't. Here's the problem most students run into. You read from the left to the right, so you have the natural tendency to say, I'm going to start with the carbon on the left. You don't do that. You start with the carbon closest to the first substituent. So let's go back to these 2 molecules. We already decided, here's our longest chain, and it's a heptane. We're going to now focus in on this substituent. It says find and name the substituents. What is that substituent? What's the name of that substituent? Louder? It's a methyl group. All right, you see why I introduced you to these 6 substituents. We're going to find these, and we got to figure out what they call them. Now, where is carbon number 1? There's 2 ends to this molecule, this end and that end. On the right is carbon number 1. Why? Because 1, 2, 3. I get to this by carbon number 3. If I started counting here, if I said this is 1, 2, 3, 4, 5, I wouldn't get to that methyl group until I got to carbon number 5. So this is not carbon number 1. That's number 1. And when you decide what is 1, it determines what every other carbon in the chain is. That's the beginning of the chain. That's the end of the chain. That's a 7 over there. Okay? Okay. Rules 2 and 3 over here. Remember, we decided this was the longest chain. It says I find and name the substituents. So this one over here is a methyl, just like the one that was on the other molecule. What is this one? Ethyl. It has 2 carbons, F. F stands for 2 carbons. Meth, 1. All right, now, where is carbon number 1? Which one of these is closest to one of these ends? Here's an end, and there's an end.
The one at the top?
Up here. Yes? Because 1, 2, 3, I get to that methyl group. 1, 2, 3, 4, I get to this ethyl group. So I'm getting to that first. So this is carbon number 1. This is carbon number 2, number 3, number 4, number 5, 6, 7, and 8. So the methyl is on carbon number 3. So So it's a 3-methyl, and the ethyl is on carbon number 5. It's a 5-ethyl. If the 5 is telling me what carbon it's attached to. It's kind of an address. Where is this ethyl group? It's on carbon number 5. Well, there's one for you to kick around with by yourself, if you like. But let's go to these other 3 rules. Designate the location of each substituent by the correct number. We've kind of done that. Assemble the name. Listing groups or substituents in alphabetical order. And use prefixes like di, tri, or tetra when there are more than one of the same substituent. We don't have any of that in these 2 molecules yet. We just have a methyl and an ethyl. So there's going to be none of these prefixes yet, but these prefixes will come into play. Ignore the prefixes when alphabetizing. So we're going to alphabetize off the name of the substituent. Methyl will alphabetize off of M, whether there's 2, 3, or 4 of them. We won't alphabetize off of these prefixes. Okay, so let's return to our molecules. Do I have them? Okay, so write the full name of the full IUPAC name of this molecule. We decided that this is here. This was 1. This is 7. It's heptane. Sorry about that. 2, 3, 4, 5, 6, 7. So this is heptane. We got a methyl group on the 3 carbon. So it's going to be 3-methyl heptane. We don't have to worry about alphabetizing. There's only one substituent here. But we do put this carbon number in front of this, and we put a dash around numbers. Okay, put dashes around numbers. There'll be times there may be a 1 in a formula, and we don't want to confuse it with an L on methyl or something like that. So put dashes around numbers. There can be a space here. You might see a space here, you might not. You might see these capitalized or not. That's not real critical. But that's the features that are critical. A number, a dash. Okay, remember now we decided this was the longest chain. I'm going back to these same molecules. We had this, and we decided this was carbon number 1. And this was on carbon number 5. The parent name is octane. Okay, now we need to assemble the name alphabetically. So what's going to go to the front of the name? Ethyl. 5-ethyl dash 3-methyl octane.
What is the dot? So it says when there's more than one steps, whatever that word is. It says
more than one of the same same.
Okay.
So you only use that if there were 2 methyl groups.
Right. Okay.
Then you'd say dimethyl.
Okay. Right.
All right?
Yeah.
Yes.
Do you always put the higher number first?
No. No, what you do, we're alphabetizing.
Oh, okay.
We're putting ethyl first here. Even if ethyl was on carbon number 3, we would put it out here. And if this was on carbon number 5, we would still put methyl here. All right? So it doesn't have to do with the number. It has to do with the letter of the alphabet.
And everything is just connected by dashes.
Well, just dashes around numbers. Okay, so I don't need a dash here,
Just around.
just around the numbers, both sides of the numbers. So the 3, is it going to get a dash in front of it and behind it? See, we're separating that. We're making sure that we know that's not a number. All right? So this is the IUPAC name. That's the IUPAC name of that molecule. Question? No?
Actually, not on this one, but the other ones that you said that we could try. I have a question on that.
Oh my. You are an overachiever. Okay, that's all right.
Okay, so it would start from the end of that last CH3 towards the right, and so it would be 3-methyl, and then 4-ethyl, right? Correct? Or is that?
I don't know. 1, 2, 3, 4, 5, 6, 7. Oh, 1, 2, 3, 4, 5, 6. So what you're saying, what's your name?
Hana.
Hana. What Hana is saying, that's the longest chain? Is that what you think is the longest chain? Hana, look up there.
Yes.
Okay, and so then we have a methyl and an ethyl. This may be close to what... Okay, so yeah, this is probably carbon 1, 2, 3, 4.
So it would be 4-ethyl, 3-methyl.
Yeah, 4-ethyl, 3-methyl, 5, 6, 7. Heptane. Yes. 4-ethyl, 3-methyl, heptane. Okay. All right, so prefix this branch of substituents in alphabetical order before the base stem name. I don't know. Halogens usually come first. We don't have any halogens on here yet. Indicate the position of the branch. Separate numbers and letters with a hyphen. Separate numbers with commas. Okay, so if there were 2 methyl groups, then it'd be 3, 4 dimethyl. Or 4, 4, 6 dash triethyl. If you see a di, there should be 2 numbers. If you see a tri, there should be 3 numbers. And notice here, I mean, we don't have a molecule to look at it here, but here's something that's a triethyl, but 2 of these ethyl groups are on the 4th carbon. We still put 4, 4. 4, 4, 6, triethyl. 2 of them are on the 4th carbon. Okay, go ahead, name that molecule. Just work on it by yourself. Scratch out the name of that. Don't shout it out. Let everybody else try to come up with the correct name of that molecule. Apply those 6 rules. Name that molecule. When you have it, let me see it. Got a name? Yeah. Don't know. You got the right substituents, but you have the wrong numbers. Look at that. Look how close it is to that end.
So it would start.
Yeah, it's going to start there.
2, so it's 2.
Yeah, there you go. Change your numbers. You have the wrong numbers here.
Okay.
Okay? See, you numbered it 1, 2, 3, 4, 5, 6. But look at this. This is close to that.
Oh, so you started this way?
Oh, yeah.
Okay.
1, 2. Not changing them. Okay. Got a name?
No.
Pretend it's a test. You got to write down a name. Okay? It's going to be a bad test. Well, that's the beauty of doing some of these in class. You don't lose any points, right? You learn how to do it. Work it out.
I think it's just straight across.
Yeah.
I'm not
So where's carbon number 1?
here.
Okay, there you go. So put a 1 on there. And that's number 2.
Did I get that right?
4. Okay. Okay, there you go. Now you're halfway there. You're 3/4 of the way there. Okay. All right, you could have either come up with this right there as the longest chain, or some of you could have said, well, that's good right there. That's 6 carbons. That's 6 carbons. And notice here, if I went 1, 2, 3, 4, 5, 6, I could go 1, 2, 3, 4, 5, 6. That's 6. And it wouldn't matter. Let me just show you. So where's carbon number 1? On the left or the right? Right. This is carbon number 1. And some of you already know what I just said. The most common error is to think that's carbon number 1. It isn't. It's far away from... You got to get to the 3rd carbon to get to here, and the 5th carbon to get to here. Here is 1, 2. You're at carbon number 2 here, 3, 4. Yeah, and this is 5 and 6, so it is hexane.
Would it be 4-ethyl 2-methyl-hexane?
Yeah, 4 ethyl
2-methyl-hexane?
2-methyl hexane. Okay?
What if we went up?
Now, if you went up, let's look at that. If you went up here like that, you would still have your methyl on the 2nd carbon, right? And you would have, this would be your ethyl group, and it would still be on the 4th carbon. Have the same name. It would end up with the same name. It doesn't matter which. So if you find the longest chain with a bend or without a bend, you've found the longest chain, and then just deal with what is attached to it from there. And then here is the line diagram of it. Here's carbon number 1, 2, 3, 4, 5, 6. And we've got a methyl group on carbon number 2. We have an ethyl group on carbon number 4. And so that is the line diagram for 4-ethyl 2-methyl hexane. And what it is showing you there is what an ethyl looks like in the line diagram. A methyl is just a straight line. A methyl is just a straight line. But an ethyl needs to bend. Doesn't matter which way it bends. And it also doesn't matter whether it starts up or down. It just has to be on the right carbon. That is an ethyl substituent.
But the line, we always started from left to right, correct? That one we do have to start from left to right? The carbon line?
No. No, I mean 1, 2, 3, 4, 5, 6. I could have this and that.
So as long as you have the
Oh, I blew it. Yeah,
I think this is a little bit up.
it could start over there. I'm kind of making this a little too long. I'm not stopping. And I can't erase a little bit of it. I touch it and the whole thing disappears. So
Yes, but as long as all the components.
for the line or this, yeah, all the components have to be there, and they have to be attached to the proper carbons. Because I mean, imagine that thing. I could twist that around, and it doesn't change the molecule, so it doesn't matter which way you start it. It just all has to be connected properly. Yeah, we'll play around with that a little bit more. Okay, let's name that one. Let's do one more. And it's giving you a little bit of a hint here. When you put the name together, you can see there's 2 methyls on there. But we're going to alphabetize off of this M, not off of this D. So a dimethyl is not going to jump in front of an ethyl. It's still methyls. So alphabetically, methyls are always come after ethyls, no matter whether there's 1, 2, 3, or 4 of them. Yeah, so let's do one more. This is where you start saying, okay, how do I apply these rules? Let me piece it all together. Rule number 1, what's the longest chain? Number 2, find the substituents. Figure out what is carbon number 1. It's not the same thing. You got 2 methyls on there. This isn't the same thing.
No, I'm saying like there's because it's 1, 2, 3, 4, 5, 6, 7, and then if you go up, it's still 7.
Right.
So it's
Still
not
7.
the same, but
Yeah.
there's 2 ways.
Right.
Okay.
There's 2 ways you could go for the longest chain, but you end up with the same number. Yeah. 1 second, Hannah.
So that's how you would write it. If there was 2 of them, would you just put the comma there and then the dash would go here?
Right, and a dash there.
Okay, but between these 2, if
And
it's
put a
2.
comma between 2 and 3. 2, 3. And what do you got? Heptane. 2, 3. Dimethylheptane. 1, 2, 3, 4, 5. Yeah, 5 ethyl. Yeah, there you go. You go. Hannah, do you have a question?
I just wanted to check if it was right.
5 ethyl, 2, 3 dimethylheptane. Yep. That's right. You gotten it?
I don't know if I'm doing that part right.
Yeah. You don't need a comma here. You need dashes here. You need commas just right between 2 numbers.
Okay.
And you need another dash after that, 3. Dimethylheptane. Yeah. Yep.
Can I ask a question? So if this is the closest though to that first one,
Yeah.
First, do you count that as 1, 2 then?
Yeah, that's 2.
Oh, it is 2.
That's 2. 3.
Got it. So I went
See,
back.
that's number 1. There's nothing on number 1.
Right,
There is something on 2, and there's something on 3.
because that was the shortest distance. From
Right.
Okay, so
Right.
you're going to count on this one. So I did it back.
Yeah, so you...
That would be 2.
Yeah, it doesn't mean you always start at the right. You start at the end, closest to the first substituent. Okay? All right, so we start at the end with the closest substituent. Longest chain is right here. Right here is the longest chain. 1, 2, 3, 4, 5, 6, 7 carbons long. So the parent name is what? Heptane. And we have a methyl and a methyl. And so where's carbon number 1? Yeah, we're on the left. All right? Doesn't mean you can't ever start on the left. If that's the end where the first substituent is, start there. So that's carbon number 1. That's carbon number 2. Number 3, number 4, and number 5. So we have an ethyl on number 5. And then what? Okay, 2, 3, dimethyl. Heptane.
Where'd you get
2, and 3.
Why is it that way for this one? Because it's closer.
Because if I started counting here, 1, 2, 3, I don't get to that ethyl group until carbon number 3. But I'm getting to this methyl group at carbon number 2. I'm getting there first.
Okay.
So when I start counting from this end, I get to a substituent sooner than if I started counting from this end. What we're going to end up with is, you can always end up with the lower possible numbers in your name. If we started over here, 1, 2, 3, I would have a 3 here, but I would have a 5 and a 6. 5 and a 6 here. I'd have higher numbers.
So just a quick question. I know that it says that ethyl before methyl or dimethyl, which I have, but I don't understand like a lot because D is first in the alphabet for E. I know. Are you just not supposed to worry about the di?
Don't worry about the prefix that's telling you how many are there.
Okay. Right.
Worry about the name of the substituent.
Right.
Yeah. So ignore that for alphabetizing. Okay, so there's one slide there with all 6 of the things. If you want to print that off and make a business card, put that on the back of your business card. Or, don't tattoo it, because then you have to leave your hand out during the exam. Or I got to get you a glove or do something. All right? Okay, draw. Let's draw a molecule. Let me draw this one, and then I'll give you one to draw. And I just show you how would I approach the name of a molecule. Well, I'm going to approach it I'm going to look at the parent name first. I'm going to deal with the substituents second, and then I'm going to fill it in with hydrogens third. Okay? So pentane. And now since I'm drawing it, this is going to be my carbon number 1. I read from left to right, so I'm not going to make it hard on myself. That's going to be carbon number 1. There are 5 of them. Pentane. So that's going to be carbon 1, 2, 3, 4, and 5. Now don't put these in your actual molecules, but this will help us right now. So on carbon number 2, I have a methyl group. On carbon number 2, I've got another methyl group. 2, 2. 3, and on carbon number 4, I have a methyl group.
Is that with the 2 and the 4 methyl?
Yes. I see there's a prefix tri. I know there's 3 methyls. I need to know where they are. What's the address of those 3 methyls? One is on carbon number 2, one is on carbon number 2, or another one's on carbon number 2, and then one is on carbon number 4. And then, okay, now I've taken care of the parent name, the chain, longest chain. I've taken care of all the substituents, and now I finish it off with hydrogens. Look, notice that on this carbon, there are no hydrogens on this carbon. That carbon has all carbons attached to it. No hydrogens. This number 3 carbon, the number 4 carbon gets 1 hydrogen, and the last carbon gets 3 hydrogens. And the line formula, 5 carbons, so I'm going to put my pen down. That's 1, 2, 3, 4, 5. And on number 2, there are 2 methyl groups. And on number 4, there's a methyl group. And that's the line diagram of it, right there. 2 2,2,4-trimethyl pentane. Okay, this is a toughie. We got our first isopropyl. Take a stab at that. Take a stab at that. It's an isopropyl group. It's not a propyl group. One, two, three, four, five, six. Yes?
I said it's just one, right?
Well, isopropyl.
Oh.
How many carbons are on a propyl?
Okay, so it's 3.
3. So what you're doing, you're attaching that thing right there. Okay? So come down, you put a carbon, and you put 2 carbon off of each one of them.
Like that?
Well, erase that. You know, you're doing a line. So put a carbon. Draw a carbon. Now attach a carbon to it.
Oh.
And attach a carbon to it. Okay, now put 4 bonds around everything. Getting there? That only has 3 bonds.
Oh, sorry.
And that only has 3 bonds. There you go. That's an isopropyl group hanging off the side of it. Okay?
Cool.
All right? You were starting to do the line of it, which is the way you would do the line of it. But this is a structural formula, so I want to see all structure, and then you could do a line formula of it below it. Okay?
Thanks, sir.
Yeah, you're welcome. Okay. How we doing?
I have put C and then HHH, but then is it just H? I had originally put
Just a line, or do I do that? And leave an empty on the bottom?
No, that's a methyl group. That's not an isopropyl group.
So then
That's a
it's
methyl.
So is this isopropyl?
Is it like that?
Well, there's where it has to attach. So what's it look like? What does an isopropyl look like? Okay, let's hexane. So we need 6 carbons. 6 carbons. And on the third carbon, there is going to be an isopropyl group. What does that look like? Well, it kind of looks like this. That's what an isopropyl group looks like. And it's going to have a hydrogen up there, and all of these things are going to be hydrogens. Remember, every carbon has to have 4 single bonds around it. This is in chapter 10. We're talking about saturated hydrocarbons. All single bonds around all the carbons. Okay? That's your isopropyl group right there. Yeah, don't just draw a molecule with this line here and a blank spot. That's not a molecule. It needs something there. That carbon needs to be attached to something. And this carbon is attached to an isopropyl group. Okay. There were several more concepts here. I know we're getting some good practice right now, but I need to get you, so draw these molecules. I'll tell you what, on Monday, I'll collect the homework. We can come back to some of these slides if you want to and say, Mr. Yak, I did that slide. Did I do it right? All right, you ask me about it. But there's 2 more concepts here. isomers. What is an isomer? What is an isomer? Isomers are two molecules that have identical molecular formulas but different structures. So let's take a look at the molecular formula of butane. 1, 2, 3, 4 carbons. This is its molecular formula. C4, 2, 4, 6, 8, 9, 10 hydrogens. C4H10. Let's take a look at this one. 1, 2, 3, 4 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens. All right? That molecule, here's butane. Here's butane right here. And if I take this hydrogen off of there and take this methyl off of there and put it there and put this hydrogen right there, I haven't taken anything away from butane, but I have changed its structure. Same number of carbons, same number of hydrogens, different structure. So butane and isobutane are isomers of one another. They're a pair of molecules that have the same molecular formula but different structures. And they have different properties. You say, man, don't these have the same properties? No, they don't. This thing boils at about 12 degrees lower temperature than this one. This one's boiling around the freezing point of water, and this one's minus 12 degrees centigrade. So they have different properties. They're different materials. They have different structures. So that's just to tell you what isomers are. Cycloalkanes. I'm doing some of this quickly, but let me just introduce you. Let's get six carbons out here somehow. All right, cycloalkanes. So here's 5 carbons. We need a 6th one here. 6 carbons. Hexane. So there's hexane. And we said, okay, it zigzags. It can zigzag. It can bend around, whatever it does. That's hexane. I can ball it up into a big ball. Still hexane. Well, hexane, notice that one end of the molecule can kind of get close to the other end of the molecule, and what happens sometimes is it will cyclize. Now, I am taking something away from here. Taking these 2 hydrogens away, and it's going to cyclize. That is an alkane. It is not hexane. It's cyclohexane. This is cyclohexane. Cyclical. Hexane in a ring. And it has a little different general formula. The general formula here is going to be CnH2n. Not H2n plus 2. I took the end hydrogens off. It's just CnH2n. There are 6 carbons and 12 hydrogens. Cyclohexane.
What's the N?
N is the number of carbons. So we could have cyclopentane. It would be C3H6. Or cyclobutane, C4H8. And let's just draw it real quickly. So if I were to draw this, draw it into a kind of a hexagon. And the hydrogens, notice here, the hydrogens are outside the ring. The hydrogens aren't inside the ring. So don't draw a hydrogen there and another one here. Okay, don't do that. Draw the hydrogens all outside the ring. That's cyclohexane. Structural formula. It's a little sloppy. If I was sitting down, it'd be prettier. All right? So yours should be prettier. Okay, now you'll love this. Line formula. That's it. That's the line formula. Cyclohexane. All right? So if you have a cyclical, if you have a molecule that's in a ring, you have to prefix its name with cyclo. You can't just say there's 6 carbons, it's hexane. Hexane is 6 carbons in a line, in a chain form. This is in a ring. So when it's in a ring, there's got to be cyclo named to it. So, yeah, there's cyclohexane. Here is 1-chloro-3-methyl cyclohexane. Okay, you're seeing a halide come in. The first time that we're kind of slipping in something other than a carbon and a hydrogen. I told you there'd be alkyl halides. Here's an example. And so the chlorine here, we're calling this carbon number 1, 2, 3. We're going to count over to this methyl group the shortest path possible. So I don't go 1, 2, 3, 4, 5 and say that's a 5-methyl. I go 1, 2, 3. It's a 3-methyl.
So when it's cyclical like that, how do you know where you could potentially start at?
Yeah, we're going to give precedence to the chloro group. Well, let me give another example.
Okay.
I'm looking for my seating chart. What did I do with my seating chart? Your name again is?
Alexis.
Alexis. Okay, Alexis. I got the wrong class. Well, that's not going to help me. All right. Okay, Alexis, let's take a look at this. Let's say we had a. So we had this, and we had a methyl group right here, and I'm going to just write it as a CH3. The B hydrogens all around there. I could just call this methyl cyclohexane. You'd say, well, wouldn't you call it 1-methyl cyclohexane? Yeah, well, if there's only one there, I don't need to put the 1, because that any carbon that has something on it is where you would start counting. But let's say I had another methyl group down here. Okay, now I need some numbers. Now I need 2 numbers actually. This is going to be carbon number 1, 2, 3. This would be 1, 3 dimethyl cyclohexane. All right, and I could start counting here. This could be 1. Say, well, why did you call that one 1? Why wasn't this one 1?
Is it because it's the least number, or?
Well, if I started here, I would go 1, 2, 3. It'd still be 1, 3 dimethyl cyclohexane. I'm not counting clockwise. I'm counting shortest path to the next substituent. So even if this one was over here. Now, that's going to be 1, 2, 3. Okay? I'm going to come around this way to get to this one, because that's the shortest path. And if you look at that, if I had this other one, drawn here, oh, what's happening?
Take a selfie.
Yeah, I did a selfie. Involuntary selfie. Movie. if I had a methyl here, notice that if I just flip this over there, this molecule would lay right on top of that molecule. So there's nothing different between this molecule and that molecule. They're identical. I'm just rotating the molecule around. It's not changing the way the things are arranged with one another. Okay. Conformations. The molecules, the chains can go into conformations, but let me use the cyclohexane to explain what we mean by conformation. Cyclohexane can go into two conformations, and one we call the boat conformation. So pretend this is a little life raft, and here is the raft part of the boat, and there's the bow, and there's the stern of the boat. So we call that the boat conformation. It says it's more strained. Why? Well, you can see these carbons are getting, and these hydrogens are getting bunched up, strained. The other conformation is, think of one of these bending down. Think of one of these bending downward and that one bending upward. And we have the chair form. I haven't changed the structure of cyclohexane. It has just changed its conformation. Follow me? It's just gone into a little different shape. And this is the more relaxed. That kind of goes along with the lounge chair. You're a little bit more relaxed. This molecule is a little bit more relaxed. This carbon and these two hydrogens have more space, and these carbons have more space than they do in the boat conformation. That's what we mean by strained. It's a little bit more strained molecule here. This is what goes into. But keep in mind, a bottle of cyclohexane, these molecules are slamming into each other. The warmer it gets, the harder they slam into each other. Things get hit, get knocked up into the boat formation. It gets bent back down into the chair formation. They're getting bounced around. They're not changing their shape. Okay, let me, I got to come back to that. Well, let me do that. We got a minute to do that. And your homework will not be due at 11 o'clock. I will collect it at the end. It's due Monday. We will collect it at the end of class or somewhere during class, okay? So what we have not covered is reactions. So on Monday, we're going to look at combustion, if you want to go ahead and get familiar with these. Combustion, and we're going to learn how to balance a combustion equation. And we're going to look at halogenation. And there may be another thing or two we have to do in there, but that's the main thing we have to do. So I think your last question, our last two questions have to do with reactions. You can leave those blank till Monday. We'll cover this topic. You'll do that, and you'll turn it in. Okay, now let me get to this. You're going to need a 3x5 card for isobutane. And this is an example of the kinds of 3x5 cards you're going to need in chapter 11, 12, 13. Why do you need this one? Because this one, its IUPAC name is 2-methylpropane, but it has a nickname. This molecule has a nickname. It's also called isobutane. You can't figure out what that structure is by applying the IUPAC rules. All right? I mean, if you came in here and your nickname was Charlie, you know, and there's nothing like Charlie on your birth certificate, I'm not going to be able to figure that out. There's no official documented way for me to figure out you might be called Charlie. You got me? You just have to tell me that. Well, I've got to tell you that isobutane has this structure. And Well, you need to know this because on the quiz, I might say, draw isobutane. Or exam 1, I might say, draw isobutane. You're gonna go pale. You go, oh no, I don't know. I can't figure it out with the IUPAC rules. No, you can't. But there are molecules like this, like acetic acid that's in vinegar. That's not its IUPAC name. That's its common name. And chemists rarely use its IUPAC name. They call it acetic acid. Okay? So if I send you to the lab to say, get me a bottle of acetic acid, you say, what do you see that is? It's ethanoic acid. That's its IUPAC name. But nobody calls it that. You with me? So there's one extra card you should have. So you should have now 10 methane to decane, 6 substituents, and 1 nickname or comment. You're going to be one molecule that has a common name in addition to its IUPAC. Yes, Hannah?
So the top carbon does not have any hydrogen surrounding it?
Yeah, it does. It does. I just didn't go that far. Definitely does.
So we should have 10 cards.
17 cards.
Wait, what are the 10 for the...
Methane, all the way down to decane. 6 substituents. Methyl, ethyl, propyl, isopropyl. And then this one molecule here that has 2 names. Any molecule that has 2 names, we won't learn every single one of them, but the ones that are indeed common names that you should kind of know what that molecule is, I'll point them out as we go through each chapter. Pardon me? Line diagram?
Oh, is it the methyl?
Yeah.
It's not the one he gave me.
Okay. Okay, I'll see you Monday. Try to do everything but the last 2 questions so that you can finish your homework in class in about 5 or 10 minutes. We'll cover reactions and I'll give you a few minutes to finish those last 2 questions. Yeah, I called attendance. What's your name? Karen, yeah. Okay, Karen. All right. All right.
The isopropyl hexane. So I got those. And then what's the iso part of it? Like what would that be off of the...
The iso part of it would be, so what is it? Hexane?
Isopropyl hexane.
So 1, 2, 3, 4, 5, 6.
And then off the third one?
Third one.
Is iso.
3. So an iso group, an isopropyl group looked like that.
Okay.
An isopropyl group
Alright.
looked like that.
Is that condensed formula right, or is it this one?
That's right.
Okay.
That's a molecular formula.
Okay.
Okay.
Now, how would you write it if it was a cyclohexane? How would you write the condensed formula for that? If it was asked.
Yeah, don't worry about it.
Okay.
But it would be.
Or if it was an isopropyl. Are those going to be asked at all or no?
You know, you might
It's right in here, actually.
write it. One way to write it would be this way.
Okay.
That's 6, 1, 2, 3, 4, 5, 6, and then they just draw a line like
Okay.
that. That's one way. I don't know another way. I guess you could do something like this. I don't know how you would. I don't know. So don't worry about it.
Okay.
I won't give you condensed formulas of cyclos.
I just want to let you know that I was here.
And what's your name?
Alyssa Garza.
Garza. You should let me know you're here.
Yes.
I will mark it late. Okay?
Would you like us to hear it in that
Yeah, this should be done when you come to lab. Yeah, turn it into lab.
Okay, you would have been okay, right? On this. I don't know if this was, I get confused with the reactive.
So this is before. You see this and this are the same. So that's before oxidized. And then after oxidized, probably would be this. Well, it doesn't, this is an oxidizing agent, that's an oxidizing agent, but this is the oxidized form of the vitamin C. So don't worry about the oxidizing agent, worry about what, right, it is a little different. I would go with this. Either one of these, but this would be fine. Okay? This is it oxidized. This is oxide. This gets a little tricky to get it onto the formula. Don't forget that little but it does get tricky because you have to figure out. See, that carbon has no hydrogens on it. That carbon has no hydrogens on it, except it has an OH group. All right, so do the best you can to get the one.